deep down inside everything we see around us, we found a universe completely unlike our own.
What does that mean?
It means that you would enter a reality where all concepts of time and space become irrelevant as you shrink for all eternity.
But the thing that I found exciting about this is that we introduced the quantum realm, a place where the laws of physics, space and time themselves, the arrow of time, right? They don't have any meaning. They haven't emerged yet.
All right, guys, in this video, we're going to talk about one of the highest levels in physics, a field that studies the subatomic world, the world that exists deep inside particles. And interestingly, this idea is also the basis of the world you see in the Ant-Man movies. Yeah, the field we're talking about is quantum physics. Or in the Marvel universe, they call it quantum realm.
Have either of you guys ever studied quantum physics?
But honestly, quantum physics is insanely hard to understand. Even Albert Einstein, one of the most influential scientists in history, was deeply uncomfortable with it. Why? Because at the quantum scale, reality starts behaving in ways that completely break normal logic. Things just stop making sense the way we expect them to. In fact, many people even call the quantum world a supernatural realm, a crossroads between what's real and what feels unreal, between what makes sense and what absolutely shouldn't make sense anymore.
To paraphrase one of the founders of quantum mechanics, everything we call real is made up of things that cannot be themselves regarded as real.
So, how absurd is the quantum world really? Well, by the end of this video, you're going to start seeing it. So get your brain ready, because some of the ideas we'll talk about might genuinely blow your mind. Let's talk about it. All right, guys, let's start this quantum physics discussion with the story of Ant-Man. As we all know, in the Marvel movies, Scott, aka Ant-Man, has the ability to change the size of his body. This ability comes from a piece of technology called the PIM particle.
He had rumors about what was called the PIM particle.
Basically, this weird red liquid was created by a scientist named Dr. Hank Pym.
Dr. Pym?
Yes.
And to activate the PIM particle, Scott has to use his regulator belt. If you remember, there's a scene where Dr. Pym warns Scott not to mess with the regulator on his belt. Because if something goes wrong, Scott could shrink all the way down to the subatomic level.
Do not screw with the regulator. If that regulator is compromised, you would go subatomic.
What does that mean?
It means that you would enter a quantum realm.
And of course, that's exactly what happens. When he's fighting this yellow dude, Scott is forced to mess with the regulator so he can shrink even smaller. And yeah, it works. He beats the yellow guy. But the problem is, Scott keeps shrinking, smaller and smaller, until he eventually enters a world inside the atom. And that is what Dr. Pym calls the quantum realm.
What does that mean?
It means that you would enter a reality where all concepts of time and space become irrelevant as you shrink for all eternity. Everything that you know and love, gone forever.
Luckily, though, he still finds a way to come back to the normal world.
Scott,
Yeah.
you're full of shit.
Oh, yeah.
All right, up to this point, I want you guys to remember three important things: Dr. Pym, the Pym particle, and the quantum realm. Got those? Good. Because now I want to introduce you to this guy. His name is Dr. Spiros. He's a quantum physicist from the California Institute of Technology, also known as Caltech.
How many of you would actually go into quantum physics?
And here's something interesting. Dr. Spiros actually worked as a science consultant for the Ant-Man movies.
I was the science consultant for Ant-Man. The physics was insane because I was the science consultant, right?
Which means a lot of the ideas you see in the film, from the Pym particle, shrinking bodies, all the way to the quantum realm, aren't just random Marvel imagination or pure science fiction. Many of those concepts are actually inspired by real ideas in quantum physics.
But the thing that they found exciting about this is that we introduced the quantum realm.
Wait, so does that mean the Pym particle is real? Does that mean we could actually shrink down like Ant-Man? Or even enter the quantum world? To answer those questions, let's shift the discussion to the actual science behind it.
Have either of you guys ever studied quantum physics?
Now, if you pay attention, before Scott actually enters the quantum world, he first passes through several smaller worlds. First, he goes through the world of bacteria. Bacteria are insanely tiny. Just to give you an idea, the size of a typical bacterium is roughly like taking a single human hair and dividing it into about 10,000 pieces. Yeah, that's already ridiculously small. But it still doesn't stop there. Scott keeps shrinking until he reaches the scale of viruses. And viruses are even more extreme. Most viruses exist on the nanometer scale. And if you remember the video where we talked about nanotechnology, 1 nanometer is roughly like taking a single strand of hair and splitting it 100,000 times. At this point, the scale is already so small that it's almost impossible for our brains to even imagine it. But even after reaching the size of a virus, Scott still hasn't reached the smallest limit of matter. He keeps shrinking, until eventually he arrives at something that forms the foundation of almost everything in the universe: the atom. I'm sure all of you remember this from school. We were all taught that an atom looks something like this. In the center, there's the nucleus, made of protons and neutrons, and around it, there are electrons orbiting the nucleus. But here's the thing. What you've been seeing all this time is just a simple illustration of an atom, a simplified model to help us imagine what an atom might look like. Because in reality, atoms are not that simple. What most schools don't really explain is that the distance between the electrons and the nucleus is actually incredibly, insanely far. To give you an idea, imagine if we scaled an atom up to the size of a football stadium. If the atom is the size of a football stadium, then the nucleus in the center would only be about the size of a pea, sitting right in the middle of the field. Meanwhile, the electrons would be like tiny specks of dust spinning around near the outer edge of the stadium. Yeah, the distance is that huge, which means that about 99.9% of an atom is actually empty space. And do you see the point here? If all matter in the universe is made of atoms, and atoms themselves are 99.9% empty, then technically speaking, the world around us should mostly be empty space too, right? So in a weird way, we're not that different from ghosts.
If the nucleus were the size of a football, then the nearest electron will be in orbit half a mile away. The rest of the atom will be completely empty space.
And that's why earlier I said that quantum physics often feels like it sits right on the border between what's real and what feels unreal. But wait a minute. If everything is mostly empty space, then why does the world feel solid? Why can we sit on a couch, lie down on a bed, or hold our phone without our body just passing right through it? The answer is the repulsion between electrons. Electrons carry a negative charge, so when two or more objects come close together, the electrons in one object repel the electrons in another object. And because of this repulsive force, the atoms in your body and the atoms in other objects push against each other instead of passing through. And that interaction is what creates the feeling of solidity in the world around us. Pretty weird, right? Just from the repulsive forces of these mostly empty atoms, we end up experiencing the solid world we live in today.
See, the rules of the quantum realm aren't like they are up here. Everything is unpredictable.
All right, now let's go back to the Ant-Man story for a second. In the movie, the Pym particle that allows objects to change size supposedly works by changing the distance between the atomic nucleus and the electrons inside an atom. So if the distance between the nucleus and the electrons inside an object is compressed, the object becomes smaller. The closer the distance gets, the smaller the object becomes. And the same idea works the other way around. If the distance between the nucleus and the electrons is expanded, the object would grow larger. Just like what happened to Scott in Avengers Civil War when he turned into Giant Man. So yeah, that's basically the simple logic used in the Ant-Man movies.
When I took over this company for Dr. Pym, I immediately started researching a particle that could change the distance between atoms while increasing density and strength.
But is there actually a technology that can change the distance between atomic nuclei and electrons like that? Well, you probably already know the answer. But there's one thing you should know. Even particles like electrons, protons, and neutrons are not actually the smallest things in the universe. Because if we go deeper, inside those particles, we eventually arrive at something called the quantum world. In the Ant-Man movies, the quantum world is portrayed in a very abstract way. Strange shapes, repeating patterns, constantly moving structures, almost like a mix of symmetry and asymmetry happening at the same time. And interestingly, that depiction isn't just random visual effects, because in reality, the quantum world really is that weird. Like particles that can exist in two places at the same time. Particles that somehow know when they're being observed. Particles that can influence each other across thousands of miles. The idea of the multiverse, and many other bizarre and absurd phenomena that really happen in the quantum world. But sorry guys, we can't cover everything about quantum physics in a single video. That would be way too long and way too heavy. So we're going to break this topic into several upcoming videos. In the next video, we'll dive even deeper into this crazy quantum world. For now, the most important thing to understand is that the weirdness of the quantum world is actually real. But even though the quantum world sounds incredibly strange and sometimes even feels completely illogical, the study of this tiny world has actually led to many real technologies in our everyday lives.
Quantum technology. Now you can forget nanotech, forget AI, forget cryptocurrency. Quantum energy is the future.
One of them is nuclear technology, a technology that can be used to generate massive amounts of energy through nuclear power plants, but it can also be turned into devastating weapons in the military. In the medical world, technologies like MRI scans and radiation therapy allow doctors to see inside the human body and treat diseases like cancer. There's also the transistor, a tiny component that forms the foundation of almost every modern electronic device, from computers to smartphones. Even the GPS technology we use every day for navigation relies on atomic clocks, which operate based on principles that come from quantum physics. And today, scientists are also developing quantum computers, a new generation of computers that work directly based on the laws of quantum physics. So even though the quantum world may look strange, absurd, and almost supernatural, it's actually this tiny world that has given birth to many of the powerful technologies we use in our daily lives. So, would you dare to enter the quantum realm?